Hi everybody, in this video let's look at transformations. So in this chapter you will be only focusing on isometric transformations. It means that after that transformations, the image will have exactly the same shape and same size as the object. So in the futures you are going to learn another types of transformations, which is enlargement. If you look at the name, you know, enlargement. The image will become bigger or sometimes smaller or sometimes exactly the same. It depends on the given scale factors. So enlargement is not an isometric transformation. So now we just forget about that first. We only focus on isometric transformations. So before that, let's look at these two terms, congruent and similar. They actually mean differently. So two geometrical shapes are congruent if they have same shape, same size. It means that exactly the same. So since that they are exactly the same, they will have same area. So for example, now if I draw an isosceles triangle, let me draw an isosceles triangle for you. Okay, then I copy it, I paste this over here. Since I copy it and paste over here, they are exactly the same, right? Exactly the same. Let's say this is A, this is B, this is C, this is P, this is Q, this is R. So these two triangles exactly the same. They are congruent. They have the same area, same shape, same size. So how about similar? So this is same shape, same size. Okay, now let's move to similar. So what similar means? Two geometrical shapes are similar if the corresponding angle are equal and the corresponding sides are proportional. If the two objects are congruent, definitely they will be similar. Why? You see, the corresponding angle of this will be this. Exactly the same, right? Equal, right? So this angle, okay, this is an isosceles triangle. So these two will be the same. They are exactly the same. So corresponding angle are equal. The corresponding sides are proportional. So what it means by proportional? It means that when you take this side divided by this will be equal to this divided by this. Okay, let me write down. PQ. The corresponding side will be AB, right? AB. So QR. The corresponding side will be BC. And PR. The corresponding side will be AC. Because they are exactly the same. When you divide, you will get 1, right? So if two objects, two geometrical shapes are congruent, definitely they will be similar. But two similar objects, it can be not congruent. Okay, so what do I mean? Okay, so now I try to make this shape become bigger. Okay. Oh, let me try to, oh, I cannot. Okay, so these shapes is copied from here. So now all them congruent. Okay, let me change. Okay, later let me change the shapes. Okay, just now I told you that some similar object, similar shapes, it not necessary have to be congruent. Sometimes it's similar but not congruent. Okay, for example, this and this same, right? Okay, now if I enlarge it, make it become bigger, I can say that, okay, let me change this, become D, E, F. Now I can say A, B, C, and D, E, F, they are similar because angle are equal, corresponding angle are equal, and the corresponding side are proportional. If you take DE divided by AB, okay, already let me write down here, DE divided by AB will be equal to EF divided by BC and will be equal to DF divided by AC. But this time it's not equal to 1 because now the shape still remain unchanged, but the size already changed. So similar, same shape, but the side can be different. Okay, so in this case, I can say ABC, triangle ABC and triangle DEF are similar triangle, but they are not congruent. Okay, so now let's go to let's look at the types of transformation that you are going to learn in these chapters. Isometric transformations, translations, rotations, and diffractions. You will notice that every time the image under that isometric transformation, the shape and the size will always remain unchanged. Okay, let's look at translation first. Translation. Personally, I feel that translation is the easiest one compared with others. So normally, we will describe a transformation like this, using a parenthesis, and we write two numbers here, x, y. So the number on the top here representing moving how many steps to your right or to your left. It's talking to your right or to your left. If going to your right hand side, it will be positive. If go to left hand side, will be negative. And the number here means go up or go down. If let's say positive, go up, negative, go down. Okay, now let's look at this one, H to I. So this is a translation. How many steps to your right? 2 steps, right? And 3 steps, 4 steps go down. 2 steps to your right, so it will be 2, positive 2. And go down 4 steps, 1, 2, 3, 4. So it will be negative 4. So the translation involved here is 2, negative 4. Now, if the questions ask you to draw the image of triangle ABC under these translations. So how do we draw it? It means that you move this triangle 2 steps to right hand side and 4 steps go downward. Okay, let's see how do we draw it. So now I'm going to draw the image of this triangle under this translation. Okay, so this is the image of this translation. You will notice that their angle will be exactly the same, the corresponding angle. Okay, so you see all the angle. I think you cannot see it here, right? 30.96, same thing. 59.04, same thing. And this is 90. Okay, their corresponding angle are equal. And these are two congruent triangle. Congruent, exactly the same. So this is the way how we draw the image of the image under a translation. Okay, now you already understand about the translation, right? So it means every vertex move 2 steps to your right, 4 steps go down. 2 steps, 4 steps go down. Here also the same thing. Okay, so another 2 isometric transformations that you are going to learn in this chapter is rotation and diffractions. Let's look at refraction first. Refractions. For diffractions, we need an axis of diffraction. It's like a mirror. So now I'm going to draw the image of this triangle when it is diffracted in this straight line F. So if we actually go this way, because this is the mirror, right? Diffract about line, okay. So it will go this way. You will notice that they are still congruent, but the orientations will change. This is A, B, C. This is counterclockwise, and this become A prime, B prime, C prime. It become clockwise. So this is one of the characteristic of the diffractions. They will still be exactly the same shape, same size, but the orientations will become will change. Okay, so this is diffractions. Okay, now let's look at the last one, which is rotation. So for rotation, we need a center of rotation. Okay, in this case, I will use this as a center. So rotation, it can be clockwise or anti-clockwise. If clockwise, it means rotate this way. Anti-clockwise, it means rotate this way. So now I just try clockwise, means going to rotate this way. Okay, so I set it to alpha, clockwise. Oh, okay, I think I need to rotate again. Okay, so now I'm going to rotate this one with this as a center. Rotate this triangle A, B, C with the point F at the center. So now rotate. So you notice that the shape and the size of the image will always remain unchanged. They are all congruent. So now I'm rotating this clockwise. If I go this, become anti-clockwise. Move this way, clockwise. Okay, so this is rotations. And the last one I want to share with you, that which you're going to learn in the futures, which is enlargement. So now you will notice that all the image that we got are actually congruent to the object, right? That's why these are called isometric transformations. So just now I told you about the enlargement. So now let's see, how do we get the image of an enlargement? Okay, so for an enlargement, we also need a center of enlargement. So now I'm going to enlarge this. Okay, now it becomes bigger. So now you will notice that the shape is still the same, right? Okay, let's see the angle. Angle still the same, the corresponding angle equal, but now the size become different, but still proportional. Okay, let's see. Now you have 1, 2, 3, 4, 5, 6, right? 6 divided by 1, 2, 3. So, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 1, 2, 3, 4, 5. Last one. Okay, I think this one don't have to calculate. This one you can just use Pythagorean theorem to help to get the answers. Okay, so you will notice that every time you get the constant ratio, which is equal to 2, right? So now these two triangles, they are not congruent because size difference, but they are similar. Okay, all the corresponding angle equal and the corresponding sides are proportional to each other. So just like I told you that it can be bigger, right? Now it's become bigger. It can be exactly the same size when it's equal to 1, when the k, it can become smaller. It can become smaller as well. Okay, here is a little bit. Okay, let me change scale factor to show you how it becomes smaller. Okay, so now it becomes bigger, right? So it can become smaller as well. Okay, now they are not congruent, but they are similar. Okay, so this is just extra information for you. You are going to learn it, enlargement, in the future. So now you just need to focus on translations. This number tell you move how many steps to your right hand side or to your left hand side. This number tell you how many steps you are going to move up or move down. And then you have, just I also show you the diffractions. You have an axis of diffractions. You need a mirror, and then for rotation you need a center of rotation. Okay, so this is just briefly introductions about the types of transformations that you are going to learn in these chapters. So in the next few videos, I will go more details about the translations, rotations, and diffraction. See you next time. Thanks for watching. Bye bye.